Alrighty, folks, we are going to go ahead and continue our discussion about motion by discussing acceleration. All right, our learning targets for today, we're continuing a little bit with I know how to calculate speed or velocity, and then we are also accompanying that with I can calculate the acceleration of an object. All right, I want you to go ahead and pause the video and set up your notes for today. Our topic is acceleration, and our essential question is how do you determine acceleration? All right, so acceleration. I think that when people think of acceleration, they kind of just think about a car going faster. But in reality, acceleration actually encompasses a much wider range of change, and besides just going faster. And acceleration, this is the rate that velocity changes. So acceleration can be described as changes in speed, because remember, velocity is a combination of speed and direction. It can also be a change in direction, or it can be a change in both speed and direction. So just imagine you're driving in a car and you're going 60 miles per hour north, and now all of a sudden you're going 60 miles per hour south. Well, even though your speed has changed the same, you are now going in the opposite direction. So obviously there was some sort of change that happened, and that's an example of acceleration. Both increases and decreases in speed are acceleration. There is no such thing as deceleration. There is negative acceleration, but increases and decreases are both considered acceleration. So you can think of tons of different examples of acceleration. Right here, I've got this fun little video of a horse playing with a medicine ball. And you can see that the horse experiences a lot of types of acceleration. You can see right there, the horse slows down and speeds back up. So those are both examples of acceleration. But the horse is also changing direction. So the horse is upright, now it's going downwards. And all sorts comes to a stop. That's acceleration. All sorts of examples of acceleration. I'm sure that you could come up with plenty of examples as well. What question does the previous slide answer? All right, so let's talk about a couple of types of acceleration that we just want to be familiar with. The first type of acceleration we want to be familiar with is called free fall. So this is the movement of an object toward the Earth solely because of gravity. So you can think about this as simply as dropping a tennis ball, and the fact that the tennis ball goes towards the ground, that is free fall. Or you can look here and we have a video of a person bungee jumping off of a big tower. I don't know about you, this would scare the crud out of me, but it is kind of interesting to see. But that person, you can see, they are experiencing acceleration due to gravity. So that would be free fall. Constant acceleration is a steady change in velocity. So your velocity is increasing at a constant rate. So in free fall, that is an example of constant acceleration because the Earth's gravity accelerates an object at 9.8 meters per second squared. Another way to think about constant acceleration would be, let's say that you are at the starting line of a race and you speed up and you're running, and every second your speed increases by 1 meter per second. So that would be constant acceleration because after 1 second, you're going 1 meter per second. After 2 seconds, you're going 2 meters per second. 3 seconds, 3 meters per second. 8 seconds, 8 meters per second. So that would be a constant increase in acceleration, or in velocity, which would be constant acceleration. What question does the previous slide answer? Alrighty, folks, go ahead and pause the lecture video, head over to Nearpod, and check out this clip that I posted. It's from Mythbusters, and they're talking about dropping a penny and the acceleration involved with that. So kind of a cool clip. Check that out. All right, hope you enjoyed that. So let's go ahead, now that we've discussed different types of acceleration, let's go ahead and talk about how we would calculate acceleration. Well, you calculate acceleration by dividing the change in velocity by the total time. So we talked about how acceleration by definition is a change in velocity. So we're taking that change in velocity and we are dividing it by the amount of time that it takes. So If you have an increase in velocity, you'll have positive acceleration. If you have a decrease in velocity, you'll have negative acceleration. So over here, and this is in your notes packet, if you flip over, there's a page on acceleration. You can find acceleration equals change in velocity over total time. You can break change in velocity down to a final velocity minus initial velocity divided by total time. So this will be the general formula that we will use. A equals VF minus VI over delta T. Delta means change in time. VF is final velocity. VI is initial velocity. So let's go ahead and try a practice problem. A skater increases her velocity from 2 meters per second to 8 meters per second in 3 seconds. What is the skater's acceleration? All right. Well, let's go ahead and go through this. Well, we have our final velocity here at 8 meters, our initial velocity here at 2 meters per second, and our time is 3 seconds. So we have everything we need to solve this equation. First thing we're going to do is let's just figure out what is the change in velocity, because we need that. So in order to do change, you have to do final minus initial. Make sure that you get those correct, otherwise your answer will be wrong. All right, so 8 meters per second minus 2 meters per second, that means our skater's velocity changed by 6 meters per second, positive 6, so it increased by 6. So then acceleration equals change in velocity divided by time. Change in velocity divided by time would be 6.0 meters per second divided by 3.0 seconds. And so if you do 6 divided by 3, you get 2. And if you do meters per second divided by second, your unit is going to look like this, m/s/s. That is basically how I want you writing the unit, which sometimes can be said meters per second or meters per second squared. But in order to get credit on Schoology, you are going to have to write it m/s/s as your unit. I know that's a little bit of a weird one, but it is important, so make sure that you get that. What question does the previous slide answer? Alrighty, folks. So now that we've made it through, we've done a little bit of practice here. I'm just wanting you to say, how well do you understand acceleration on a scale of 1 to 5? Go ahead and answer that, please. Alrighty, folks. We just went through a lot, and honestly, acceleration is all about practice, 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 practice. So first things first, please make sure that you finished your velocity practice and that you have that down, because you do want to understand velocity fully before you start working on acceleration. Once you have velocity down, then I want you to go ahead and work on your acceleration practice. These are pages 14 and 15 in your packet. Lots of problems to work through. If you head over to Schoology, you will find tutorials that walk you through how to do acceleration problems, and you can find a few of those. And then on top of that, you'll also find a key to this practice on Schoology as well. So check your answers as you go. Make sure you're doing them correctly. You can also always reach out to me, and I would be happy to work through some problems with you on a meet. So just kind of schedule that, and we'll make that happen. Also, please remember to take Quick Quiz 2.1 before the end of the day. That is your attendance. Alrighty, folks, have a wonderful day.